Hello everyone, welcome to the course Data Science, and today's topic is outlier noise and anomalies. So we know that we have been discussing outlier many times in the previous previous lectures. So in that, so this is one example for outlier. See, the data are concentrated, but only few data are away from this. So this is called as outlier. But when you consider outlier, you should learn this anomalies as well. For example, if you run faster and if you take the BP, definitely it will shoot up. And take one more case on BP patient. For them, it is always the blood pressure is high. So in this case, one is not serious, but this is serious. So the serious one is anomalies, and the this not serious. It is for temporary, mean that is called as outlier. So outlier is due to some measurement error, or that is only for a particular instant, or if it is influenced by one particular factor, that's it. But anomalies means it is to be considered properly, it has to be treated properly. So we are going to see that, and how we are going to address it, or how do we find whether this particular data has a outlier. Okay, so outlier noise or outliers are the data points which deviate significantly from the norm. Okay, so outliers can be a single data points or a subset of observations. Outlier data points can greatly impact the accuracy, reliability, and outliers can also be called as abnormalities, discordant deviance, or anomalies. So outliers, but whether it is serious or it's not serious, so that we have to find from the data. So there are two types of outliers. One is global outlier, another one is contextual outliers. So let's see one example. So I'm just recording temperature during summer, and I'm just recording temperature during winter. Okay. So here I'm recording like, so the temperature in Chennai is 30 degree and 36 degree and 40 degrees sometimes. And by mistake, because suppose if there is an error in the measuring device, then it may record as 100. So by seeing this, we can say this 100 is the outlier. Then I'm recording winter temperature. So winter temperature is 24, 28, 26, and 30 and 40. Okay. So in this category, which one is outlier? 40, because 40 is impossible during winter, but 40 is possible in summer. So this 40 is outlier only for winter, but 40 is not an outlier for summer. This is called as contextual. So this 40 is a contextual outlier because one for particular category it is outlier, but the same value is taken or is to be considered for the other category. So that is called as contextual. That is, in one case it is taken, in the second case it is not taken. Okay, so this is your contextual outlier. Whereas next case 100, 100 is impossible in India both in summer as well as winter. So in both category it is not taken. So that is called as global outlier. So this is the difference between contextual outlier and global outlier. Or if some student is good in sports, okay, if some student is good in electronics, some student is good in robotics. Okay, so if a student, for example, A, B, C, and the other student, he doesn't know anything because he just attend the classes. So that person will name it as D. Okay, so in this A person is accepted in sports, or that A person cannot do well in electronics, that A person cannot do well in robotics. So A person is a contextual outlier because he is welcomed in sports, but he is not welcomed in electronics and robotics. Whereas B person is good in electronics, but he is not good at sports, but he is not good at robotics. So B person is also a contextual outlier. Whereas C person, he is good at robotics, but he is not good at electronics, he is not good at sports. So he is also a contextual outlier. But this D guy, he doesn't know sports, he's not good at sports, he's not good at electronics, he's not good at robotics, then he is a global outlier. So this is the difference between global and contextual. So global means it is outlier forever, whereas a contextual means for one range, for one category it is an outlier, for other category it is to be considered. So this is the difference between global and contextual outlier. So global outliers are isolated data points that are far away from the main body of the data. They are often easily to identify and remove. It has to be identified easily. Whereas contextual outliers are data points that are unusual in a specific, not in all contexts, but may not be outliers in a different context. So this is very important. For a specific context, it is unusual or outlier. For other contexts, it is not an outlier. They are often more difficult to identify. It's very hard to identify whether this person is outlier or not, and may require additional information or domain knowledge to determine whether it is a contextual outlier or not. But global can be identified easily. So how do we find this? So one is global outlier. So we have given the definition already. This is one example. So how do we find? We are going to use z-score. So z-score is x minus mu by sigma. And here we are going to fix the range. I mean interquartile, lower bound and upper bound. So either we can use detection methods like z-score, or you can use interquartile range or box plot. With these three, you can easily say that whether it has outlier or not. Give an example. So take the data and convert into a data frame, and I'm going to apply the z-score. So z-score formula is the value minus mean divided by standard deviation. So already I found all those values, and I'm going to check whether each value, each data has some z-score, whether that's z-score, because it has to be absolute, because we don't need to take minus value. Absolute, for example, the first value means, so z-score, so z-score value is minus 0.407 dot abs, means it is considered as 0.407 only, absolute value. Then we have to check whether it is greater than 3. No, it is not greater than 3. So that is that means there is no outlier. So like this, you have to categorize, or you have to calculate for all the data, and for this data it is greater than 3. So that's why it has an outlier. So by seeing the data itself, see, these are all belong to some cluster, whereas this 50 is far away. 50 is far away from this. So this is an outlier. So this can be easily identified using z-score. Whereas, and then here's the reason why do we have I mean, why do we have to use z equal to greater than 3? Because 68%, this is the rule, 68, 95 and 99.7. I think in the last slide I have given 88, but that's wrong. 68, 95, 99.7 rule. 68% of the values within one standard deviation. Second one is second standard, third standard. But after this, whatever comes, that is an outlier. So that is 3%. So that is why in z-score we have to fix the value 3. If it is greater than 3, then there is an outlier. So outlier, global outlier can be found by using z-score. And next one is contextual outliers. So this is appear normal in one context but is abnormal in another. So we can say an example, temperature, or the grocery spending. So the detection method is time series analysis, clustering, domain specific rules. Okay, for example, time series analysis means this I mean, in machine learning we have this algorithm like autoencoders. Using that also you can find. And clustering is, suppose you have some various clusters. Okay, so here suppose if this point is there, means we have to find this one by finding the distance. So in that way you can find whether this point is a contextual outlier to this gang or this gang on this gang by using this k-means algorithm. Next one is domain specific rule, that you yourself make a rule. For example, in a family, the maximum spending is 30,000, 30K. Okay, so the family has to decide. Suppose I mean, unfortunately, they spend 35K, means they always think that, okay, if it crosses 32K, then for them it is a outlier. For example, in another family, they may fix 50K is outlier. In that family, 35K is acceptable. Whereas this family, A family and A family, if it crosses 30 itself, it is a outlier, but 35K is not outlier for this category. So this 32K or 50K or 10K or even 5K, these are fixed by the domain specific rules. Okay, so it depends, it is customized. So it is domain specific based on the situation, based on the expertise, we can fix it. So let's take an example. In the previous lecture, we have seen that there are three methods to identify contextual. One is time series analysis. Another one is some any clustering method. Another one is domain specific rules. Okay. So in this, the domain expert fixed that, okay, 20 is the outlier, is the threshold for the outlier. Any data which falls above 20 means that is considered as outlier. Any data falls below me, that is a normal data. So I can fix 25. So why should I fix 20? I can fix 25. For example, so you can take any event. So for that, they have fixed some number of entries. Okay, number of entries. So if that is fixed with 50, this is a normal. Okay, so for this they have fixed some date also. Within 3 days it has to be sold out. Okay, so within 3 days, if they have not received enough number, or if the tickets are not sold, then they will increase to 5 days. So now initially they have fixed 3 days threshold, but due to the scenario they have increased the threshold to 5, and then sometimes 7 also. Sometimes they'll give 1 month also. So this variation, this threshold variation, is dependent on the domains and the situation. So it keeps varying. So you have to fix that. So how do we fix that? So we can take a plot. So this PLT is obtained from this matplotlib.pyplot as PLT, and plot is the function. So for that we need x data, y data, and marker is wo. Oh, this is wo. This is wo, and the dot, the style is this line. Likewise it plots normal plot which we do using scale in the graph. And this ax means axis horizontal line. So the threshold is marked as a horizontal line axis, and here the threshold value is 20, but it is varying, and the color is red, and line cell is like this. An unusual threshold, this is not a standard threshold. So this is called as contextual outliers. And one more example. So you can use some formula also. Some every value that has to be absolute. There should be no minus. When you subtract, you may get minus and plus. If it is minus, convert into plus. So you have to take the difference and check whether it is greater than particular value. This 10 is fixed by the domain expert. You can change the value also. So accordingly, you can fix the outlier. If it is greater than that, then that is outlier. So in this data, based on the equation, 40 and 60 is outlier. So this equation is not standard. It is different from person to person or domain to domain. And the next one is significance of outliers. So we all know that if there is an outlier, then it will be a biased models. So outliers can bias a machine learning definitely, because this one value can change the entire model and towards the outlier value, so leading to poor performance on the test data, and this can be particularly problematic. For example, I mean the score for a particular subject is 50, 55, 60, and yeah, and 100. Okay, so the averages, so let's take 65 or easier thing. So 65, 70, 120, 170, 270. 270 by averages, so it is 6, 4, 7, 4, 20. Okay, 6 fours. 6, 4, 24. Remaining 30, so 7. 7, 67, sorry, 67. 67 point something, okay. So by seeing this, one can deny it. Oh, okay, this class percentage is 67 percentage. So better, I don't need to train them. But it is a wrong data, because only one is 600, but the others are, they are around the average only. So they need training. But based on the value 67, they may think that, okay, this class has got very good score. So we don't need to train. So in this class, these three guys are suffering. So this leads to poor performance of the rest of the data, or wrong modeling also. So your accuracy is reduced, then your variance is increased, and reduced interpretability. So your interpretation may go wrong because of this. So hence, outlier has to be treated properly, or you have to find outlier and remove it. Better thing is you can remove it. Then anomalies. So a data object that deviates significantly from normal objects, such as unusual credit. So this is anomaly, because outliers can be anomalies. If there are some instances that they're very rare in the data and have features that differ significantly from most of the data. And anomalies can be context outliers, which are anomalies that have values significantly deviate from other. But simple thing is, outliers are standard statistical deviations that may or may not be significant, but anomalies or deviations that indicate something unusual or potentially meaningful. So that is the difference between outliers and anomalies. But this can also be detected using Z-score and the other method, time series analysis, clustering, k-means clustering, or any domain specific rules. In that way you can identify. But whatever it is, outlier has to be found. Sorry, outliers has to be found, and it has to be treated properly. Treated means you have to remove that particular anomaly or outlier. Okay, thanks for watching. That's all for today. Thank you.